Okay, I think it's recording now, so you can go ahead. Show us the just a brief. I mean, can you just walk through the slides first, so that because yesterday I mentioned certain corrections, right?
Uh,
I emailed you certain corrections
yeah,
last night, so
yes.
you incorporated it, right? So I just want to have a quick look, even before you go into the presentation and start delivering the lecture. So can you just okay? Can you press the arrow button? Yeah, yeah. Background procedure. One minute. Procedure. Procedure is the workflow, right?
Yeah.
Execution is like your code. Configuration, code structure, requirements, differences, issues. Okay, fine, yeah. And then, okay, so then, then. This is the procedure.
Yes.
Oh my god. Okay, fine. I wanted a workflow, one by one, the block by block. What activities inside? Uh, what I wanted is a big block and then small activities inside, and then the next block. So when you say reverse engineering, dx dar, what will they do, and hashing, what are the options, those kind of things. Okay, fine, go ahead. Then next, execution. Okay, okay, okay. This is from the mail. Can you go to the first, the reverse? Yeah. mm, okay, then no locals, no optimize. Okay, okay. Code structure is what, your code structure or the one that is present already?
Sorry?
This is your code structure.
Yes.
Okay, then this is okay. Okay, okay, fine. Quickly. Yeah, yeah. Then okay, I think you can start. Try to be a little louder.
Um, Today's presentation will be about library detection using DOIT and APK lesson. It's based on reverse engineering and hash. So this is the Viva-Kit repository of my implementation of DOIT. So first, I will introduce some background knowledge and the basic idea of this technique. And then I will talk about the detailed procedure to perform library detection and how to execute my code. And next is some configuration we need to pay attention to, which is specified by the authors of DOIT. Next is the code structure of my implementation and some system requirements, like what kind of software you need to install to run the code. And finally, I will discuss some the differences between the current implementation and DOIT and APK lesson, and some issues I noticed in the implementation.
Okay, so you can interrupt her whenever you have any questions, and I will also. It's not very formal. You don't need to sound so formal. It's like a discussion, but we just save it for future references. Okay, so you can feel free and you can interrupt and you can respond and all that, right? Okay, please go ahead.
So first, what is a library? A library is basically a jar file or maybe several jar files, and it's like this. So a jar file like this. So so you can open it. You can see that the jar file is basically a collection of some class files, and the jar file has a special directory structure, which is the reverse of the package name. So like for example, the package name of these four files is s.google.com. So they will be placed under directory com/google/s.
I think this is a very important point for you also. The introduction that she is giving is very important because you may, I don't know, but I think it's quite
So
important.
this whole thing is a library, right? The jar file, you mean?
Yes, the
Yes.
whole jar file is a library.
Okay.
Can you show us some examples of some reverse engineered library also? Like this is a jar file which is during the forward engineering, but at the same time you might have reverse engineered certain libraries, right?
You mean the mapping between package name and directory
No.
structure?
Some example of reverse engineered libraries. After reverse engineering, how the libraries will look, because that is exactly what we are going to find, right?
It's a folder.
After reverse engineering.
Yes.
So I reverse engineer this one.
Yeah.
So you can see many classes. This is in the root of the folder, and go to com and Google and ads. So you will find these four classes.
These houses are a library.
These are library class files.
The ads folder.
Yes.
Yes.
Okay. So what about the parent folder, the Google folder? Is it a library? Or
No, it is a mixture of both add and not add, because the parent folder contains analytics also. At the same time, it also contains some Android support routines. So you cannot label Google simply as
a library.
An add library.
So like com, Google, Analytics is maybe another library.
But how do you differentiate a folder whether it is a library or
We have a list of the package name.
this a package name?
Yeah. So
No, he's asking how do you differentiate a library and a non-library code.
Yeah,
So we maintain a
folder.
database of libraries. So she will explain that in due course. Okay, now you can move on to the presentation.
okay.
So this is obtained by using what tool? The class files. What tool did you use?
The class first there.
APK tool. Is it?
Basically two.
No,
Or
APK
dash,
tool
I think.
will get the small file.
So this is DAR, right?
Yeah, this is the I will talk about here. So next is the process of Android application compilation. So these are the source code written by the developer. They will be compiled into class files, and the developer may use some libraries. So the library is in the format of a Java. So the class files and the Java files will be compiled into a single text file. And this is only this is a single file. So all the code are mixed together. So you cannot differentiate which part of this file is written by the developer, which part of this file is a library or another library. And the text file and some other resource files like some pictures, some drawables will be compressed into an APK file. So this process from the class files to an APK, it can be performed by the Android compile tool, Android build tool called DX. So this will be used in our
So DX
implementation.
is an Android build tool.
Yes.
So it's by Google, and they give us to make our own class files, integrate them with libraries, resources, and then make an APK.
Yes.
So that's a whole compilation process is handled by DX.
Yes.
Okay, I think you also experimented with some DX versions, right?
Yeah, there are
So
several
what is-
versions.
What will happen? They different DX versions. How do they differ? They combine the class files, library files. Say we have DX version 1 and version 2. So will the class files, library files, resource files, all of them packaged into an APK, will the DX version 1 give the same output or
No,
different
they
output?
will.
In terms of hash, I'm asking. When you actually make an APK from DX version 1 and DX version 2, will the hash codes be the same?
They may be different.
They may be different.
So in the paper, in the DOE paper, the author said they use 4 versions of DX, and 2 of them produce the same hash value.
Okay, there are 4 versions of DX and 2 of them produce same hash values.
Yes.
Can you number them? What
It's
versions?
it's not specified in the paper.
Okay, fine. So you actually, do you observe only 4 versions of DX? I suppose we observed 16 versions of DX.
No, actually, Android build tools. Android build tools.
There are, I think, 20 or different.
No,
20.
Android build tools is a collection of tools.
Yeah.
So the version of of Android build tools will be not the same as the version number of DX.
Okay,
So for example, I have this version number
Okay.
19.0.0.
this is for the build tool.
This is yes for the Android build tools,
Yeah.
and it has several. This is also one of
AAPT
the-
is one of the build tools.
Yes, so you can check the versions of DX using this command. So I can go to local Android build tools like 19. So and I check the versions of DX.
Oh, okay.
So you can see the version is 1.9. 1.8 is not 19.0.0.
Okay, so how many different versions did you check?
How many different versions? I have the build tools from I put in another file from in 17 to 17.0.0 to 21.1.2, and they belong to is in the later size. So 17 to 18 is belong to 1.7.
Oh, okay.
19 to 20 belong to 1.8.
Okay.
And 20 to 21 belong to 1.10. I think this 1.10 is not the same as this 1.1. I think 1.1 is earlier than 1.7. So I think these three versions they may be too old, so I cannot. So it's not available online.
Okay, you mean to say 1.1, 1.2, 1.6 are very old and not available online, but
Yeah.
you conducted all your simulations with 1.7, 1.8, and 1.10.
Yes.
Okay, so how about 1.9? Is it missing?
So
Okay, so it's kind of not very stable, so we cannot take a call on that. Maybe it's not released itself. Okay, fine, so go ahead.
okay, so
Okay, till now you have made the case of how you forward engineer and integrate the library into the APK. Okay, now we proceed to the
yes. So
Yes.
just as I mentioned, the text file is a single file, so the code are mixed together. So we need to separate them. We need to use reverse engineering. The process is called retargeting. So we will use the tool called there to retarget an APK into a collection of classes. So after retargeting, these classes are also arranged into directory based on its package name. So if a library contains the Google S, if an app contains Google S library, so the package name is s.google.com. So the files will be placed under com/google/s. And also like Amazon S, the cost of Amazon S will be placed under com/amazon/device/s. So they have their directory structure. So after retargeting, we are expecting like if an app contains a library like Google Ads, so we can find the classes of this library in this app. So the files will be the same. We are expecting this, but actually it will not be the same. Like the original files may contain some debugging information. So this debugging information, after we use it in the app, we compile it into an APK and then reverse it, and then retarget it to class files. This information will not be recovered. So the original files will not be the same as the retarget files. So do it for a process called double reverse engineering. So just like we compile an app and retarget it, we can compile an library Java to an APK and then retarget it to compile an library Java to a mini APK and then retarget it back to some to the class files. So these class files and the class files from the app go through the same build and retarget process, so they will be the same.
Wait a minute. So this background section, this particular block diagram that you're explaining, is the exact procedure suggested by Duet.
Yes.
So Duet says take a jar file, and that is from the library website. The jar file is taken from the library website, right?
Yes.
And then make an APK
Yes.
with that library by using the build tool
Yes.
of your choice, and then you again supply the built APK
Yes.
to DAR and get a set of class files. So these class files is what Duet will use in its
Like
database.
Yes.
Okay, so my question is like, how can you build an APK without source code? Because you have the Google Ad Library, so you download it from the web page. But how do you make an APK without the source code? Because you need source code and library to make an APK, right?
Yes.
The library, you don't need the source code. You can just use this jar file. So
So where did you get the jar file?
Okay, let me ask you this question. Like, there will be a main activity for every app. Without the main activity, an app cannot function. It's like a main method in Java program.
I
So
think
when you
maybe the APK will not function, like we cannot
I know. It's not a functional APK. It's a dummy, or it's a. It cannot even work. You cannot install the APK on any phone or another device. I understand that, but is there any compilation requirement which will prevent you from making an app with just the ad library or any library? So you given a jar, any type of jar, you can make an APK out of it, right?
Yes.
Are you sure?
Yes. They also give us their command to.
Oh, so you
Yeah,
randomly
APK.
choose any of your jar file, even if it's not developed for Android itself. You can take a normal Windows jar file,
Java is a collection of
Java
Java
class
classes,
files.
yes.
Yeah, what I'm trying to say is you are actually writing a Java program which is a game on Windows computer. Okay, it will run only on JVM and not on DVM, because these jar files
yeah.
they are compiled for DVM, right? So my question is, any jar file for that matter, even it's developed for JVM, will it be compiled by DX2?
Java is developed for JVM,
Yes.
and what is developed for DVM is the text file.
Yes.
So this one is the same as any kind of Java files. So
Okay.
even if you take a Java from Windows,
It should work. So that's
Yes.
your response. I know. It's why I'm asking is there are certain syntax which is not, which a jar file, if it contains, it will be not working on JVM. But anything that works on JVM should work on DVM also, right? I think it's not required at the moment. But your answer is like, irrespective of what type of jar file it is, you can straight away make an APK out of it by using DX, right?
Actually, I'm not very sure.
Okay,
But
in your
it-
experiments, what did you do? You downloaded from the web page of Google Ad Library,
Yes.
and you just built a DX. You just built an APK without any other code.
Yes.
Okay, that's fine. Okay.
Okay. Double reverse engineering. So how can we check whether two files are the same or not? We use a hash. So a hash of a file is basically a string. So if two files are the same, they will produce the same hash values. And do it use normal hash like MD5 or SHA
256.
256. And APK listen use fuzzy hash. So fuzzy hash is to measure the similarity between two files. So it will give us a value of similarity. So
What is the range of the value?
0 to 100.
100 means highly similar.
Yeah.
0 means completely dissimilar.
Yes.
Okay.
So use fuzzy hash will be not as strict as normal hash, because in normal hash, even if two files are different only on just a letter, they will produce very different hash values. So
But fuzzy hash will it produce exactly same or close?
based on, I think it's a relative value based on if it's a very very big file and only difference in one letter, they will produce the same.
What type of fuzzy hash you used? Was it SS deep?
Yeah.
Okay.
Can we introduce more about fuzzy hash?
I don't know how it works.
Okay, you just call the method, right?
Yes.
Okay.
Fuzzy hash, I think maybe I can show you certain demos later. Let her proceed.
So in conclusion, how do we perform library detection? So we will download the library jar files and then build it, retarget, and calculate the hash values.
And make a database out of it.
Yes, and this process will be used to make the reference database. And then to check whether an app contains a library, similarly we will retarget the application and then calculate the hash values and calculate this value with the database. So this is the high level idea. So I will talk about the detailed procedures. So there are basically 2 steps.
Okay, so from here on, it's going to be fully detailed. There is no background information, right? From here on, we will go into the precise details of your implementation, right? Okay.
So to build the library reference database, so we will take a library jar file. We use dx to build it to an APK, and then use there to retarget back to class files. So and then we will use fuzzy hash or normal hash. Actually, in my implementation, it's fuzzy hash. We will get for each library, we will get a library hash. Library digest here means library hash.
Okay, 1 minute. You are mentioning about your Bitbucket repository. I think there is only one version in the Bitbucket repository, right? The history of your full development is only in the GitHub.
No, actually, I also checked GitHub, but the history is the same. So I think maybe in the first so
My question is, I also want a version where you actually had the normal hashes rather than SSD.
I think it's not
Checked in.
I think it's not checked.
Oh, but actually, we discussed it, I remember, initially before we started doing the malware detection. I think we spoke about it and you said it is performing very poorly and the detection rate is very, very poor. And after that, we actually thought of moving to the fuzzy hash. Do you have a version of that in your computer?
No.
You're sure?
Yes, I
In
think
your local Git, I'm not asking the GitHub, but your local Git.
No, my local GitHub will be the same as the.
So you push everything to GitHub.
I think at first when I started this implementation, I didn't put the code into GitHub, and maybe after using fuzzy hash, I put the code into GitHub.
So that version is lost.
Yes.
Okay.
But MD5 is very easy to use.
What do you mean very easy to use?
You can check the Python library and then the Python you can check the library the Python documentation and then use the MD5.
So you mean we can re-implement it?
Sorry?
We can redo it.
Yes.
Okay, go ahead.